All right, here we go. We are going to factor today trinomials. How many terms do trinomials have? Three. Okay. Just like a Triceratops has got 3 horns. All right, so let's play the game really quick. If I want a product of 10 and a sum of 7, what are my magic numbers?
2 and 5.
2 and 5. Yes, sir. Yes, sir. Okay, now look here. I've got x plus 2 and x plus 5. If I multiply these together by distributing, I get x squared plus 5x plus 2x. 2 times 5 is 10. Now, let's look at where the 10 came from. The 10 came from multiplying 2 times 5. 10 is a product. Okay, where does the 7 come from? The 7 comes from adding 5x plus 2x, which gives me 7x. So the 7x is a sum. Okay, so when I make my trinomial, x squared plus 7x plus 10, my c is my product, and my b, oops, I wrote c again. My b is my sum. Okay, everybody happy with that?
Yeah.
Okay, perfect. Okay, so we're going to use our magic numbers to factor a trinomial, which has 3 terms, into a product of binomials. How many terms does a binomial have?
2.
Yep, they have 2 terms each. Okay. All right, so at the beginning in our warm-up, we looked at how we might potentially use factoring to solve, but there are other reasons that we might want to factor as well. We might want to find sides of geometric figures. We might want to rearrange to find important pieces of information. So sometimes our directions will ask us just to factor, and then other times we'll have to use factoring as a means to solve a quadratic equation. Okay, so the front we're just going to factor for factoring's sake, and on the back we'll use factoring to solve. So here we want the pair of binomials that multiply to each trinomial. Those directions just mean factor. Okay, and then we're going to check our work by distributing, because factoring and distributing undo each other. So we should end up with what we started with. All right, so let's play the game. Here's our B, here's our C, our A is 1. So we're going to multiply to the C value. Sometimes my 6's look like B's. So there's the C, and here's the B of 5. Oh, yeah, 2 and 3. So in order to get x squared, don't we need, ooh, that was lopsided. Don't we need x times x to get x squared, right? Yeah. Mm-hmm. And then in our other 2 empty spots, we can put our plus 2 and our plus 3. And that's done with the factoring. Okay, that's number 1. Okay, second thing we have to do is check our work by distributing. That's number 2. So x times x we said would be x squared. X times 3 gives us 3x. 2 times x is 2x. 2 times 3 is 6. We have like terms to combine. That gives us x squared plus 5x plus 6. Check. Easy peasy, lemon squeezy.
I like these lemons. Take lemonade.
Okay, I would say that maybe we don't need to do B. Do we need to do B?
Yes.
Okay.
Yeah.
All right, let's do B. What do I know? All right, so our A is 1, our B is -2, and our C is -8. So we want factors of -8 that sum to -2. So 1, 8,
2 and -4.
2, and -4. You are correct. So get your parentheses ready. We know that it's going to take an x times an x to get x squared. And then we just put in our +2 and our -4. And that's part 1 done. Part 2 is that we have to check by distributing. Blah, blah, blah. So x times x, x squared. X times -4, -4x. 2 times x, 2x. 2 times -4, -8.
Yes, it was warm, miss. I have to support you.
Okay, combine your like terms and you get x squared minus 2x minus 8. Boom. Good? Good? Okay. So, what do we know? Okay, they're giving us an area and they want us to find the sides. What do we know about the area of a rectangle? Yeah, the area of a rectangle is the length times the width. So if I multiply the length and width together, I get the area, which is a product. Which means that the length and the width, because they multiply to a product, are my factors. Okay, if they give me a product, how do I find my factors? What process that starts with F should I use to find my factors? Factoring. Okay, so if you didn't know, write this off to the side. Factor to find factors. Kind of makes sense, right? All right, so we're going to multiply to -12. We're going to sum, add up to 11. 112, 2, 6, 3, 4. You're close. What? Oh, -1 and 12. Okay. So that would be x minus 1 times x plus 12. And we can say that this one is the width and this one is the length. And we can even check our work by distributing. X times x is x squared. X times 12 is 12x. -1 times x is -x. And -1 times 12 is -12. Combine our like terms and we get x squared plus 11x minus 12 for our area. Okay, what kind of factoring did we learn how to do last week? Yeah, where you can like find a GCF and divide it out. So last week we did ones that were like this, right? So we factored out, we got our parentheses ready. We found a GCF like -7. What power of m can I take out?
1.
Correct. What power of n can come out?
1.
Good. So if I divide that out, I get m cubed plus, just kidding, a positive divided by a negative gives me a negative. 42 divided by 7 is 6. N to what power? Yeah. Okay, that's what we did last week. So if I look at this example, do you see the GCF? It's 2. Can I take any x's? No, because this one doesn't have an x, right? So I can factor out a GCF. Whoops. Brain fart, brain fart. I meant to put it underneath the line and I wrote it up high. Okay, so number 1 is the GCF. So that's 2. So what's left in our parentheses? X squared minus x minus 6. Good. What is the coefficient here in front of this x?
1.
Yeah, it's a -1 right there, right? So our next step is to use our today stuff and factor the trinomial, the leftovers. Factor leftovers. Okay, so we want the factors of -6 that sum to -1. One, yeah, 2 and -3, good. Okay, so I still have to keep my GCF out in front. And then I can write x plus 2 times x minus 3. So be very careful. Make sure you factor completely by looking for a GCF first and foremost. And then don't stop. Make sure that you try and factor the leftovers. It doesn't say start factoring and stop. It says factor completely. Right?
Yeah.
Okay, let's flip. Okay, I promised you that we were going to solve by factoring. Yep. Yep. After factoring, we can use our zero product property to solve, but our equation must equal 0. I think I might have too many examples on the back. So if we need to go back and do 5A, we can. I'd like to skip down to example 6A. And there's an extra 0 on there, so you can just scratch that out. That was my bad. I think I tried to move it from one side to the other and forgot to get rid of it. Okay, so what I want to do is see if I can get this written as a pair of binomials multiplied together in factored form so that I can use my ZPP. We know we need an x times an x to get x squared. We just have to find what the other parts of the factors are. So we get to play the game. We want to multiply to 9, and we need to sum to 6. Any ideas?
0 and 6. 3, 3.
3 and 3, that's it. Okay, now I can use my ZPP. So I'll have x plus 3 equals 0 and x plus 3 equals 0. What do they both give me? Yeah. So how many times do I have to write -3 in my curly brackets? Just the once. So what this looks like is normally we have to let a quadratic cross the x-axis twice if it wants to. But sometimes it's like, no, I'm going to have the same root twice at -3. Do you see how this opens up because it's got a positive a value? Okay, this is going to come down, hit the x, that was crooked. It's going to come down, hit the x-axis and bounce off. So whenever we have only one solution, it's because it's repeated twice. Isn't that fun? Because it doesn't cross and come back, it just goes bing and bounces off.
Great. That makes sense.
Okay, good. All right, let's go back up and look at example 5b. Okay, compare 5b to 6a. What's different about it?
There's no 0 to 10.
Yeah, we don't have a 0. We need a 0. Because in order to use the ZPP, we have to have our factors set equal to 0. So there's no point in trying to factor until we get that 0. It's pointless, futile. Okay? So what we need, guys, is standard form set equal to 0. So it'll look like this. ax squared plus bx plus c equals 0. So does everybody see that I can move the 10x to the other side and get a 0 where it was? Okay, so that's what my plan is. I'm going to just pop it over there. Now the question is, do I put it in the front, in the middle, or at the end? In the middle, because it's going to be my bx term, okay? So if you can think about that beforehand, it'll save you a bunch of steps where you have to rewrite it, because everybody hates that. It's time consuming. And it uses space. Okay, so we're going to put it in the middle. If it's positive on the left, what is it on the right?
Negative.
Negative. So it'll be negative 10x over there. So we have 0 equals x squared minus 10x plus 9. Now we're ready to go. We're ready to play the game. We want factors of 9, our c value, that sum to negative 10, which is our b. Whoops, I wrote c. If you get your terms in the wrong order, you're going to get confused at what your b and c are, and it's going to mess up your magic numbers. Yep.
Are the factors -1 and -9?
They are. -1, -9. Good. She is good. Okay, so 0 equals x minus 1 times x minus 9. Now we're ready for our ZPP. So we say x minus 1 is 0 and x minus 9 is 0. You can probably solve these in your head. Did you get 1 and 9? Good. My ear itches, sorry. Any questions about that? Okay. Do I need to go back and do this one?
No, I think we got it all under control.
Okay, then let's do 6B. Sorry that we're kind of jumping around a little bit. Okay, What's wrong with 6b?
What was the question?
What's wrong with 6b?
Oh, shoot. It's equal to 9.
Yeah, it's equal to 9x, not 0. So we need a 0. We're going to subtract away the 9x to the other side. Are we going to put it first, second, or last? Okay, second. And it's going to be negative 9x. So we'll have 3x squared minus 9x minus 30 equals 0. What else is weird about it? 3, 9, and 30.
Wait, hold on. What?
What?
No, hold on. What was the question?
They all have a what in them?
Oh,
A factor of 3. Do you all see it? We have a GCF.
I didn't know
Yes.
that.
Okay, so we have a GCF on this one. Oh. So I'm going to factor out my 3. Okay, that leaves me with x squared minus 3x minus 10. Now I'm not done yet because I still want to use the ZPP. I'm going to try to factor my leftovers. So are there factors of negative 10 that sum to negative 3?
Negative 2 or 5 and negative 2 and negative 5.
2 and negative 5. Okay, good. Okay, so leave the 3. And then we'll have x plus 2 times x minus 5 equals 0. Now we have 3 factors. 1, 2, 3. You see them all?
Yeah, I see him. Yep.
If we set the 3 equal to 0, does that give us any solutions we can use? Does 3 ever equal 0? No, this one's garbage. We don't care about that one. All right, so then we have x plus 2 equals 0, and x minus 5 equals 0.
Negative 2 and 5.
Correct. Negative 2 and positive 5, and then put them in curly brackets. Now, it's pattern time. When my root was negative 3, what were my signs in my intercept form? Positive 3, right? Okay. When I had a negative 2 down here, I had a positive 2.
Yeah.
When I had a positive 5, it came from a negative 5 in my factor. So what I want you to do is use that pattern and write me an equation in intercept form. Y equals x,
Oh, wow.
x, and I want you to find the rest of the factors. I want the roots to be 2 and 5. Positive 2, positive 5. What will the signs be in intercept form?
I was wondering one day.
All right, what did you guys get?
Negative 2 and 5.
Yeah, x minus 2 and x minus 5. Okay, last thing I want you to do is convert it to standard form. Okay, so you're going to have to FOIL. Do your extended distribution. Go. Did you get x squared minus 5x minus 2x plus 10? Did you combine your terms?
Yep.
And then did you get y equals x squared minus 7x plus 10?
No. I did not.
Okay, don't forget your y equals because you need an equation. Without the y equals, it's just an expression. Okay, that's it. That's all she wrote.